This is an example of recursively reversing a linked list. And the first thing you should know is how to get to the code that we're using for the sample. So if you go to this site, sites.google.com/site/UIC102, then click on C Notes, and then under C Notes go down to linked lists, and under linked lists then we have several different examples that develop the notions of a linked list. And in particular this one here, which is ReverseListInC.avi, and the accompanying handout, which is the trace that we're going to be following right down here. So when we take a look at this handout, the handout looks like the following. First thing to remember is how this linked list is built, so we can see what it looks like when we run the program right here. So we have input of 1, 3, 5, and -1. So for the first input of 1, what happens is the linked list puts the value of 1 and then has a null. And then when we get the next input, we prepend another node which connects to the existing node, and the next value of 3 is placed there. So this is our second input. And then we get the third input of 5, and the input of 5, this connects to the list. Input of 5 goes on there. And then when we get to the input of -1, then we just ignore that. We don't store it on the list. So we end up with the pointer to the head of the list pointing to that list, and then this node is the node at the end of the list. So what we're going to do recursively then is we want to send this list to a function, and the function is going to end up reversing this so that the head pointer is going to end up pointing to the last node, and that node is going to point, we're going to reverse the links, and then what used to be the first node ends up being the last node. So that's the end goal. There is a section of code that we have to look at here. Actually, let's see first what happens. So here's the code that actually builds the linked list, and this is code that we've seen before. You should be familiar with this before you go on in the example. And we display the list, and then here is where we have to start paying attention specifically to what happens. So first thing we do is we have a temporary variable that makes a copy of the head of the list. Then we call this function, and with that function we take the return value, which is going to be what used to be the address of the end of the list, but now that's the address, the new address of the front of the list. That becomes the new head of the list. And then the last thing we have to do, very important, is we have to update the end of the list so that it's equal to null. Otherwise we end up with a problem. So that's what we're going to do in just a moment. So when we call this code to reverse the list, when we send it to head, that comes over here to this code, which is where we're going to focus most of our attention. And there's one line in here, and I'd like to highlight what this line does. So when we get to it, I can just say, oh, and remember what that was. So what that line does is, given a particular node, it reverses the link. So let's say we have a situation that looks like this, and we have some values in here. This is just a for instance. And we have p head would be the pointer that points to this node, and then this would be pointing, say, somewhere else on to some other node. And what we're going to do is we're going to take this pointer right there and reverse it so it points back that way. So this code takes the node following the one that p head is pointing to and reverses it to point back to me, essentially, right, to where this one is. So if we take a look at this code and parse this, we see that we have p head arrow p next. So that first p head arrow takes us into the box, and then the p next portion takes us right there. So what is that? That's the address of this node. okay? And then we take the arrow p next portion of that. So we are dereferencing, let's hang on a second here. We are dereferencing so we have this address, which is this node. So we dereference that address, which takes us into the box, and we have the p next portion. So here is the p next portion right there, and that's what's going to be changed. And it's going to be changed to the value of p head, which is this. That is to say, the address of that node. So the net effect of all this is that we're going to take the address here. Let me clean up these lines just a little bit. And we're going to delete that and make it point back like that. That's the point of this line. So when we get to it, we'll just refer to that and say, remember, it takes the pointer from the next node and make it point back to this node. So that's what it does. All right, so let's go into and do the setup here for this. And we're going to be using different colors as we do our trace. And let's move this over to make sure that we get all of the code into the window here. All right, I think that's good enough. So we start out and we say ptemp equals phead. So down in our code we have ptemp, and we pass in, of course, phead is currently the head of the list, so we have phead is the address of the beginning of the list, is the address of this node. And when we say at line A right here, ptemp equals phead, what that does is it says, okay, ptemp also points to the beginning of the list, like that. So we're done with line A. Then we go to line B, and we're going to have to go off and make the recursive calls before we finish this. So this is a call to reverse list, and eventually when we finish reverse list, the return value here is going to become the new head of the list. And the recursive calls are going to go through these nodes in turn, and eventually we end up with the address of the last node. So we can see that we make recursive calls in here, and ptemp ends up with the return value from each of those. So those return values get passed out of the recursion. We end up the return value ends up being the address of the last node on the list, and that's what's going to get returned all the way back out. And so we'll take a look at that as we go. So we make our first call to reverse list, and we send it this value phead. And so we come in, and now we're going to draw for different colors here. So the first color that we'll do is this will say that this one is blue. And so we have the value of, we come in and we have phead, and that is equal to the address of this first node. And then we declare node star ptemp right here at line 2. So we also have ptemp. This is used for storing the return value, but we don't store anything into it. Eventually what we'll get there is the return value of the last node. And we get to then line 3 up above in the code up here, and we see it says if phead arrow p next is equal to null. So if phead, here's phead from the perspective of this function, arrow p next, that is to say, is this thing null? Is this the last node on the list, is what this code here is asking. So this is not the last node on the list, so we come down to line 5 to the else, where it says ptemp equals, and then here we make the recursive call for reverse list. And so we call reverse list, and we send it phead arrow p next. That is, we send it the arrow of the next one. I'm missing one very important element, which is when we first call this list was already built, and this list already looked like that. My apologies for leaving that out. That was the list when we first came into this. So we're making the recursive call here to reverse list. So phead arrow p next, which is this, which is the address of the node, so that's what we send. So we come in here, we catch p head, and what is p head at this next level? P head is the address of the second node. And then here we have at line 2, from this second layer of the recursive calls, we've got ptemp, which isn't assigned to anything yet. So remember, when we eventually return, this is going to be assigned to something, but it's just not assigned to anything yet. Similarly now, from the perspective of green, eventually that'll get the value of the last node on the list, but we don't have anything in it yet. So from the perspective of green, we ask and find out, is this the last node on the list? In other words, is this null? No, it's not, so we come in here into the else section of code, and then we make a recursive call from the perspective of green. Ptemp equals reverse list. So ptemp equals, we're going to store something in here, but we can't finish it yet until we finish making this recursive call. So we make this recursive call, we'll call reverse list, and we send it p head arrow p next. That is, we send it this, which is the address of this node in memory. So we make the recursive call for the last one, and we catch, and now from the perspective of this last one, we've got p head is the address of the last node on the list. And then we've got ptemp declared also from the perspective of gray. So here's ptemp. It's not assigned to anything. And then we ask this question, if p head arrow p next is equal to null. In other words, if this is null. Is it null? Yes, it is. So now we return p head. So we return p head, which is the address of the last node of the list. When we return p head, we come back to the section of code, which is right here where we made the recursive call, and we now have a value for this, which we're going to store into ptemp from the perspective now of green. In other words, this ptemp is now going to get the value, the return value. So from the perspective of gray, gray has returned p head, so it's going to return this value, and that value is what's going to get stored into ptemp. So we actually do that. The return value for gray, which is the value of p head, gets returned into ptemp, and we draw that to say that ptemp now has the address of the last node of the list. And that's as we're returning back out. So this gets assigned on the way out. I'll put it in red. It gets assigned on the way back out. And so now from the perspective of green, we finish that line. So now we go to the next line down here, which is line 7, which is right here. And this is the line that I said earlier. Remember, when we get to that line, what we're going to do is we know what that does. So p head currently points to this list, and what that line does is it says, take the next node and make it point back to this node. And so that's what line 7 is going to do right now. So instead of a null in here, we're now going to have this point back like that. And that's what p head does from the perspective of green. And then line 8, return ptemp. Well, what is ptemp? Ptemp right now is the address of the last node of the list. So that's the return value. That's going to return back to blue. And so from the perspective of blue, we had not finished the assignment here for ptemp yet, right? We weren't able to finish that assignment yet because we didn't have the return value from the recursion, but now we do. The return value of the recursion is this, which is the address of the last node. So that gets returned back and gets stored into ptemp. And so we end up with ptemp has the address of the last node of the list. There. So this has an address in memory of that node. That's what the arrow means. So now from the perspective of blue, we've finished line 6, so we go on to line 7, and remember, we know what line 7 does. Line 7 says, for a given node, take the node that's to the right of it and make it point back, right? And so that's what we're going to do here. This, instead of pointing that way, is now going to point back like that. So we now finished line 7 from the perspective of blue. We get to line 8. It says return ptemp. What is ptemp? It's the address of this last node of the list. From the perspective of blue, when we return ptemp, we're going to return it back to the original caller, which was back here at line B. And in line B, now we have a return value from the recursive call. That return value is the address of the last node of the list, and that becomes the new value for p head. So p head used to be the address of this node, but now p head, oh, I was going to in red say one of these values, but now p head gets the address of the last node of the list, and so now p head points, oops, let me do this in black. P head is the address of the last node on the list. And so we've now finished line B. And the last thing we need to do is line C, and what line C does is a little bit of cleanup. Notice that now we have the this is the new head of the list, and it points to this node, which points to this node. However, we need a null right in here, which we don't have. That's the last remaining piece we have to do. If you don't do that, then you're going to get stuck in an infinite loop when you try and traverse this list. So that's the last step at C right here, which is say ptemp arrow p next. So it's ptemp from the perspective of the outer part of our program over here. Ptemp arrow p next, that is to say this portion, equals null. And so we cross that off and put a null there instead, and now our list is null terminated. Now when we display the list, when we traverse the list, we send it p head. P head is now, if we look at p head is now the address of the last node, which itself points to the second node, which itself points to this third node, which is then null terminated, and everything works the way we want it to work. You have to pay careful attention to these lines. This often is a final exam question if you're watching this video for the purpose of taking a class. So do pay attention to that. So what if we didn't want to do it recursively? What if we wanted to do it iteratively? So maybe you think, well, all this recursion is kind of confusing. Oh, by the way, I recommend that you download this program and then you try and do the trace yourself as I've done here, just to make sure that it makes sense to you. You can follow what's happening with the layers of the recursion and the parameters as they're being passed. This is an excellent example encapsulating variables, parameters, if statements, recursion. So it's it wraps together a lot that we've studied this semester. So let's take a look then back at the original document, and we were talking here that if we did it iteratively, that we'd have this line would be the call to the function, and then the function itself would look like this code that's given here. So this, in this situation, again, we could draw our list and watch and see what happens. This code needs 3 pointers to make it work. So let's first of all give ourselves a list here of, say, 3 nodes. So that's null. And we'll have our head pointer that points to the front of this list. And this is connected. And let's say we have some values in here. And let's say, so this is our list. And then recursively, when we make this call, remember p head, that is this, is going to end up changing. It's going to be the return value, which is going to end up being the address of the last node. But that's the last thing that will be done. When we call this function, we send p head, which is a node star. And then we have these 3 pointers that we declare. So we've got previous, so we send p previous, and that gets set to be null. And then we have p current, and p current is set to be equal to, actually this is the first time in, so I should do this in blue here. So p current is equal to p head, so it's the address of that node. And then we have let's see here, I'm just thinking the best way to do this. Yeah, Yeah, it's fine to draw it in black because it's iterative, so we don't need to keep track of the layers. So previous and p current and p next. So as I said earlier, previous is null, p current is equal to p ahead, which is the front of the list, and p next is also equal to null. So here we go through this section of code, and we can number these lines 2, 3, 4, and 5, and say line 6. That's pretty good. So line 1, while p current is not equal to null, so p current is not equal to null because it's currently the address of this node, it's not null. So we go in at line 2 here, say p next equals p current arrow p next. So we advance p next. So p next equals p current arrow means go into the box and dereference p next, which is this part, which is the address of that node. So the address of this node gets stored into p next. So instead of null, this now points there like that. And then that's line 3. That's line 2. Then line 3, p current arrow p next equals p previous. So this is where we do the reversing of the pointer. So p current arrow takes us into the box. P current arrow p next. P current arrow p next equals p previous. Okay, yeah. So p current arrow p next, which is this part, that's what we're going to change. And equals p previous, which is this, which is null. So this is going to go away, and it's going to become null. So we're just actually going to erase it here and put the null in there like that. So that's line 3. And then line 4 and line 5, we advance the pointer. So p previous equals p current. So p current is currently that. So p previous then becomes the address of that node. And line 5, p current equals p next. So p current gets updated equals p next, which is now becomes the address of this node right here. So on each time through the loop, what happens is we advance p next to go past what p current is pointing at. All right, so we go back up. While p current is not equal to null, p current is not null, it's the address of this node. So we say line 2, p next equals p current arrow p next. So let's see, p next, this is what's going to change, equals whatever this is pointing to and the one after it, which is the address of that one. So p next from line 2 points there. Line 3 is where we reverse the pointer. P current arrow p next equals p previous. So p current arrow takes us into the box. The p next portion is this portion right there, equals, so this is what's going to change, p previous, address of the previous node. So this is going to go away, so we can erase this line, equals p previous, so this thing goes like that. And now we advance the pointers. So previous equals current, so previous doesn't point there, but it points up here to current. And line 5, current equals p next. So current equals p next, like that. And we're still in the while loop. While p current is not equal to null. Is it null? No, it's the address of this node right here. So we go to line 2, p next equals p current arrow p next. So p current is going to change, equals p current arrow, go into the box, p next, this portion. So in other words, p next is now going to be equal to null. So we store the null into p next. That's line 2. Line 3, p current arrow p next equals p previous. So p current arrow p next, that's that, equals this trailing pointer for previous. Okay, so this null pointer goes away, and this points to the previous node like that. And then advance the pointers. Previous equals current. So previous, that one goes away, equals current, so it points there. And current equals next. So what is next? It's null. So current equals null. And we're back up to the top of the loop, and we check our ending condition while p current is not equal to null. Well, it does equal to null. So we stop the recursion, and the last thing we have to do is return the new head of the list, which is p previous, which is currently the address of the last node on the list. So when we return the address of that address of the last node gets stored into p head, so that goes away, and p head ends up being the address of the last node, and the list has been reversed. So there you go, either recursively or iteratively. It requires some thought, and I commend it to you as a good example of some of the details that incorporates a lot of what we've learned this semester. Enjoy.